Good afternoon to one and all. So in last class, that is on lecture 2, we discussed about the basics of air conditioning. There we also discussed about what do you understand by psychrometry, what is meant by psychrometric properties. During the lecture, we discussed about the DBT, WBT, dew point temperature, relative humidity, humidity ratio, specific humidity. So we discussed about some basic concepts, and today in this class we are going to explore another few topics in connection with air conditioning. So which involves the lecture title is cooling and dehumidification and the layout of unit and central air conditioners. Yeah, so in this lecture we are going to discuss about what are the different physical processes involved in a air conditioning. I told you the air conditioning means, I hope you have gone through it, supplying and maintaining a desired internal atmospheric condition irrespective of external conditions. And while defining the air conditioning, I told you that it involves a simultaneous control of air purity, air motion, temperature control, humidity control of the air inside the space which is to be conditioned. So while discussing about the physical process involved in a air conditioning, yes, we need to manage all those stuff. So in order to achieve air conditioning, the processes which we discussed now, like air purification, temperature control, humidity control, and air motion or the air circulation, how to be managed properly. Now let's see one by one. These are the different processes like air purification, temperature control, humidity control, and air motion or air distribution. The first one would be the air purification. Yes, as the name implies, it is something purifying the air, isn't it? Which means the air taken from the atmosphere, we know well that it carries lot of dust particles, some odors, bacteria, and those stuff are very harmful for the human health. So in order to eliminate these equipments, it is necessary to remove these ingredients or all these harmful products from the air before admitting into the air conditioning system. Therefore, the air purification consists of different steps. As I mentioned over here, it involves air filtration, air sterilization, air ionization, and odor suppression. Which means you need to filter out the air, you need to sterilize it, you need to ionize it, and you need to suppress the smell or the odor. See, most of the dust particles which will be removed by this filtration process, and the bacteria which can be eliminated or it can be killed by air sterilization, and then similarly the other process too. And the second step would be, like air purification, the temperature control, or you need to or it is the cooling. Maybe usually if you are living in a the temperature of the environment is very high, say above 35 or something like that, it is well known that the comfort temperature for human system is nearly around 20 to 25, and you need to lower this temperature, isn't it? That's a temperature control. Depending on, maybe sometimes if the temperature outside is very low, maybe around 0 or minus degree, you again need to control the temperature. You need to rise the temperature to the comfort level of human beings. So you need to so for the temperature control, regulate the DBT, I mean the dry bulb temperature, by various psychrometric processes. It can be attained by simple heating or cooling in association with the humidification process. Um, the cooling of air means lowering the DBT or the dry bulb temperature. And how can we achieve this? And it can be attained by passing the air over evaporator coils of a refrigerating system. Which means if it is a small room, maybe your living room, assume it is your living room where the air conditioner is kept, and that air conditioner, the intake air is forced to flow over the evaporator coil directly. In such case, the RH value or the relative humidity value is neglected, or such order that it gets adjusted by itself. So which means the direct evaporation. But in most of the cases, an indirect evaporator system is used for cooling the air. In such cases, what actually doing is chilled water is used to cool the air, or the chilled brine solution. While discussing the vapor compression system, we have seen the refrigerant vapor which is passing through the evaporator coil, which was nothing but the brine solution, isn't it? So that chilled water or the brine solution, after absorbing heat from the air, rejects heat to the refrigerant in the evaporator. So which means the heating of the air to rise the DBT can be achieved when it is required. As I told you, if the temperature is very less, the outside temperature is of the order of 0 degree or very well low temperature or minus temperature, you need to increase the DBT value. And how can you achieve that? By passing the air over the heated surfaces. And usually these heating surfaces are usually located outside the room, outside your living room. The room which is to be conditioned. ഏത് റൂമാണോ നമ്മൾ കണ്ടീഷൻ ചെയ്യേണ്ടത് അതിന്റെ ഔട്ട്സൈഡ് ആയിരിക്കും we put this heating surfaces, and this heated air flows to the room by fan function. The warm air heating system and the different so as I told you, you can see in this slide, the heating of the air means rise the DBT, and there are different type of system like warm air heating system, hot water heating system, steam heating system, electrical heating system, different energy which is used for heating. Among this electrical heating system has limited applications, and it is only used where the electrical energy, this electrical energy is where the electrical energy is cheap, you can use it. So usually its application is limited. And the third important process involved in an air conditioner is the control of the humidity control. So there are two processes which means the humidity control can be achieved by either by humidification, which means increasing the humidity, or decreasing the humidity or dehumidification. So dehumidification means the process of reducing the water vapor content of air. You are reducing the water vapor content. So how can you accomplish this? I have shown you the two. It can be accomplished by the use of an air washer or by the use of absorbent. Now in the case of first method, which means when you are going to use an air washer, the air is passed through a chemical, so it's called the drying agent. The air washer is a drying agent. It is passed through an air washer or a drying agent. So the moisture in the air enters into this chemical, and combining with this chemical, which means there is a chemical combination with this drying agent. Usually the sulfuric acid, ammonia, which means H2SO4, NH3 are the normally used drying agents. And the second method is by the use of absorbent. There are material having the capacity to absorb the moisture. So they are generally used as the absorbents. For example, activated alumina, calcium chloride, silica gel are used as the material to absorb the moisture. So two techniques, one is air washer or drying agent and an absorbent. And similarly, the humidification, what we discuss now is dehumidification. So in the case of humidification, it can be accomplished by addition of steam or hot water to the air. Different type of humidifiers are there. One is steam humidifier, atomization type humidifier, impact type humidifier, forced evaporation humidifier, etc. So among this steam humidifier is one of the simplest types which is used where the steam is directly injected into the air using a nozzle. We can increase water vapor content in the air. But for the comfort air conditioning or for the human air conditioning, so this type of technique is very hardly used because the temperature control is difficult and again carries odors which are not suitable for the occupants in the room. And again, the second type is the atomization type humidifier. As the name implies, you are going to spray, you are going to atomize the water into the airstream. So there will be some kind of compressed air which is used to draw water from the supply tank and blow it in the form of fine spray, fine mist into the duct. So in this duct, the air is carried to the conditioned space. Through this duct, the air is carried to the conditioned space. So in the duct, this fine spray or atomization is taking place and thereby increasing the water vapor content. And another type is the impact type humidifier. Again, here also some kind of spraying is happening, which means it makes the use of a fine jet of water and which is allowed to target against a hard target, and when it impinges on it, it breaks up into fine spray and the air is forced into the chamber using the fans which pick up the water by evaporation. So maybe sometimes the eliminators are placed in the top to remove if any water droplet which is carried in the air. So our idea is to make it as a increase the humidity, which means convert the dry vapor into wet vapor. And the fourth one would be air distribution. So what would be the objective of the air distribution is to create a proper combination of temperature, humidity and air motion in the conditioned space. So it is recommended the temperature variation should not exceed, so sorry, I marked it as 20 C now, it's 2 degrees Celsius. I tried to put this zero as a superscript, but it was not happened here. So the temperature variation should not exceed 2 degrees Celsius. And again, the air movement inside the room is allowed, the allowable range is 7.5 meter per minute to 15 meter per minute. So these are the four processes you must keep in mind. One is air purification, you need to purify the air, you need to control the temperature, whatever it is required, which means high temperature or low temperature, and then humidity control, humidification or dehumidification, which means either dehumidification means reducing the water vapor content, or humidification you are going to increase the water vapor content, and finally the air distribution. So all these four processes are very important in an air conditioning system. Now we are going to discuss about two important systems. One is window air conditioning system or unit air conditioning system, and then we are going to discuss about the central air conditioning system. The window air conditioning system, which is the one which we are nowadays used in many of your houses as a split AC. Now, so this window air conditioning or unit air conditioning, you can see one figure which I have shown here. This is actually one of the air conditioning system which is used in very earlier days. I'm sorry. And here you can see that you may have observed this kind of air conditioning system in many of the older buildings or older houses, where one side is inside the room, and the other one side is protruded outside the wall of the building. So this is actually a figure which shows the window air conditioning. A schematic diagram is shown below. You can see, if you look at the diagram, you can see that. So the entire setup is consists of a case divided into two parts. One is an outdoor unit and indoor unit. When you discuss about the unit air conditioning, it has two units. One is an outdoor unit and indoor unit. Now the outdoor part, it consists of compressor, condenser and a fan. And similarly the indoor part, if you look at the diagram here, you can see that this one is you can see, look at the point of the outer part and the indoor part. So the outer part consists of a compressor, a condenser, again you can see a fan. Similarly in the indoor part, again consists of an evaporator and a fan. So you can see that a capillary tube is provided between the condenser and the evaporator. You can see, if you look at the diagram which is marked with a pointer, you can see the capillary tube which is placed between these two, like the condenser and evaporator. As the name implies, the outer portion, of course, it remains outside the window or the room, and inside the room the dampers, you can see, if you some kind of dampers are provided in front of the indoor portion for changing the direction of airflow, or maybe to ensure the uniform flow of air inside the room. And maybe the working is some kind of similar what we discussed in the case of a VC system, I mean the vapor compression system. What actually happening is, initially the low pressure vapor is drawn from the evaporator, which is compressed to very high pressure and is delivered to the condenser, and from in the condenser this refrigerant vapor is condensed by releasing the latent heat of condensation to the surrounding air. And what happens, once the air absorbs the heat from the condenser, this hot air is maybe the hot air is driven out using a fan. The high pressure liquid refrigerant enters into the capillary tube where the pressure is reduced. Now the low pressure liquid vapor enters into the evaporator, and the liquid refrigerant then evaporates by absorbing the latent heat of vaporization from the surrounding air. So this cold air is delivered to the room where conditioning is required using a fan. So the direction of flow of air can be changed using a damper, which I have told you initially. If you want to change the direction of flow, which maybe with the help of the damper which is placed in front of the indoor unit, you can change the direction of flow. So if you look, I can explain to you once again. Now you know that in the case of a unit air conditioning system, you have two parts. One is outdoor part and an indoor part. You can see what are the different type of elements which constitute the outdoor part and an indoor part. Look at the damper. So this is actually the room where the cooling is required. You can see that the cold air is to the room. So inside the room, which is the indoor part, this is the indoor part where this part requires the cooling. Okay, so this is actually ultimately what is happening here is the liquid refrigerant evaporates by absorbing latent heat of vaporization from the surrounding air. The liquid refrigerant evaporates by absorbing latent heat of vaporization from the surrounding air. And once the air becomes cold, it is delivered to the room using a fan. And here again, the low pressure refrigerant vapor leaving the evaporator is again go to the compressor and compressed to very high pressure, and high pressure vapor condensed to the condenser, and likewise the cycle of operation repeats. Now again, the central air conditioning. The central air conditioning is another important most important type of air conditioner. It is used when the cooling capacity required is 25 tons or more. or when the airflow required is more than 5 meter cube per hour, or when the different zones in the building has to be air conditioned. Under these three conditions, the people are opting for central air conditioning. So in this system, all the components of the system are installed in a separate central room. And what happened is the air which is conditioned, that conditioned air is distributed through the ducts. The conditioned air is distributed through the ducts from the central room to the various rooms to be air conditioned. I told you there is a central room where all the equipments are installed, and from the central room, whatever room you have to air condition it, it distributes this conditioned air to all such rooms. So let's go through the few topics which we discussed. So we discussed about the physical process involved in an air conditioning. This is purification, temperature control, humidity control, and air distribution. And we have gone through all the processes in detail. And then we discussed about the window air conditioning. Please note that it's also called unit air conditioning. Has two parts, one is outdoor part and indoor part. And then we discussed about the central air conditioning. Thank you.